Hello, I welcome you all. The problem reads that the force of F is equal to 50 newtons is applied to the cord when S is equal to 2 meters. If 6 kg collar is originally at rest, determine its velocity at S equal to 0. Neglect friction. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So let's draw the free body diagram. So we expect the force to move, okay? So let's call this distance here as S prime. So we call this point 1 to 2. Okay. Alright, so here we have S1 equal to 0. And then here we have S2 equal to S prime. Okay. And then we do have the weight like so. Okay. And then we have the normal force. So this is the normal force, and this is the weight, which is equal to mg. Right. So using the principle of work and energy, KE1, which is the initial kinetic energy plus the total work, from 1 to 2 is equal to the final kinetic energy 2. Then our kinetic energy 1, maybe before I do so, let me define certain parameters that we're going to be using. So we have V1, which is just equal to 0 because the system is at rest. And then we do have S1 that we just defined equal to 0. Then we have V2, which is equal to V, that's what we are looking for. And then we have S2, which is just equal to S prime. And then S prime here is going to be equal to, because this collar is moving up to here, so when it reaches here, we'll have this length. Okay, so to find this change, and then this will have lengthened to this point. So to find S prime, we need to find this, subtract it from 1.5. So let me show this. So here we are going to have 1.5 squared plus 2. This is equal to 2. This one here, it is 2 meters. Okay, this is 2. So let me just show it. This is 2. 2 squared, and then we have something like so, and then minus 1.5. Then S prime will just be equal to 1.5 squared plus 2 squared, square root of that, and minus 1.5, and this gives us 1. Okay, and then we have now KE1, which is just going to be equal to half mv1 squared. The kinetic energy is always going to be positive, so we have half, the mass is 6 by v1, which is 0. This is just 0. Then we have K2, which is just half mv1 2. This is equal to half by 6. This is the mass of our column times v. Okay, and this is just 3v squared. Then we do have the total work done from point 1 to point 2. The total work done from point 1 to point 2. So again, when we have the force in the same direction with the displacement, we call this positive work. It's a simple way of understanding this. When we have the force and the displacement in the opposite direction, and you can call this negative work. So we're going to be using this concept. So when you look at the force here, F is in this direction, and the displacement is in this direction. Therefore, we have positive work. So this is just going to be equal to F times S prime, and which is just equal to 50 times 1, right? And this is equal to 50 joules. So writing the whole equation, we have the following. And this is what we have. What do we have? We have 0 plus 50 equal to 3v squared, and our v squared is just equal to 50 divided by 3, and then squaring both sides like so, and we'll find that our value of v is just going to be equal to 50 divided by 3, the square root of that. Find that is a 4.08. Therefore, our V2 is just going to be equal to 4.08 meters per second. Okay. So, of course, this is the final solution for our problem, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.